Okay, so now I'm going to be teaching you about trigonometric ratios of the special angles. Listen very carefully. Special angles. And the special angles are 30 degrees, 45 degrees, and 60 degrees. As we continue on this topic, we will actually try to figure out why are they being referred to as special angles. I'm going to be honest with you and guide you in terms of how I figured out why they refer to them as special angles, and we will just stick on that understanding until we get to the real reason. But for now, we will just keep it simple. But maybe before we discuss the trigonometric ratios of special angles, I think it is very much important that we understand the concepts involving the surds. So just maybe be aware that there is something called surds. The only way to spot a surd, that's if you see a square root. So maybe let me just take you through a quick, just a very quick lesson regarding the additions and subtractions of surds. Not only that, I will also go to the part for multiplication of surds. So let me just write it down there to say addition and subtractions of surds. Just remember that additions, I'm just talking about adding, and then subtractions, minusing. So that means we're going to be adding or minusing the values that involves the square roots. So maybe as example A, let's say we have 2 square root of 6. Maybe let's plus it with, let's say, 5 square root of 6. An answer to this, you don't need to use a calculator, but it should be 7 square root of 6. It might not be easy to understand how I knew it, but I'm going to be honest with you and say, think of it as 2, then square root of 6, let's take it as x. Then we plus it with 5. Is it still square root of 6? Yes. If that is the case, then it means it is still x. If it was a different square root of something, then it wouldn't be x, it would be something else, meaning a different letter. So you look at this, you realize you've got the like terms being 2 of the square root of that, 5 of the square root of that. That's why I'm saying 2 plus 5, it is 7 of those square root of 6. So interpret it in that way. Not that much complicated, trust me on that one. Maybe let's do another example. Let's say we have 7 square root of 3. Maybe let's plus it with what? Let's say 3 square root of 7. Maybe let's minus it and say 5 square root of 7. Yes. Let's maybe do it this way. Just be careful there. This is 7. Okay, then it's fine. What will this be equals to? So it's like you have 7x plus 3. It can't be x, then it will be y. And then minusing, it's like 5y, because it is still square root of 7. So that means this one, it will definitely just be 7 square root of 3. it's only these two that you can work them together, because it is 3 square root of 7 minus 5 square root of 7. So it's like you're saying positive 3 minus 5, what will that be? Will it not be minus 2? 2 of what? Of square root of 7. So this thing is like you had 7x plus 3y minus 5y. That is why it ends up being just 7x, because you don't have another x, and then this and that will definitely be minus 2y. So just always interpret it that way. It is as easy as that. Okay, and then it's fine. We did the additions and subtractions of the surds. So now let's do multiplication of the surds. Let me just write it down like I did for that one. Say multiplications of surds. And that. Okay, then it's fine. So let's see. Let us say for some reason you are given, okay, let's maybe do this as a. Let's say you have square root of a. And this square root of a, let's say it is multiplying square root of b. Nay. So the answer for this one, it will be 1 square root, where that a now multiplies with that b. So instead of you doing 2 square roots, you do 1, and then you multiply whatever that is inside that square root, of which the a value should be greater than 0, even the b value should be greater than 0, because otherwise, if not, it's going to give you an error. So it's like I'm saying, if you take your calculator and say square root of any negative number, it will give you an error. So but you won't need to worry about that, because I'm expecting that you will be given a valid surd. So that's how you would work it out. Maybe let's say now you have something of this nature, where you have, let's say, square root of a, and then we close this, and then we say squared. So this one, it is actually the same as 2 of the same thing. That squared, it means 2 of exactly the same thing, which is like you are having a square root of a multiplying another square root of a. That's what I mean when I say 2 of exactly the same thing. And based on that law, not necessarily the law, but we said you don't need to do 2 of square root. You just do 1 square root, and then you will say a multiplying a. This one is interesting. It doesn't end there, because inside you have the same basis. So you can't write a and a. You just write 1a, but you add their exponents. Then it becomes that. And what we know is that square root of squared, it is the same as just that number. Remember, if you have what? Let's say if you have x squared, which is equals to 4. When you have a square root, or you put a square root, automatically it removes that 2, and then you have x, which should be equals to, that alone will give you 2. Maybe let me make use of this opportunity to make you aware as to what the square root is all about. So just be aware that square root, you always have an invisible 2 there. You always have an invisible 2 there. It's like when you say x, you always have invisible 1 there. You always have invisible 1 there. Unless, for example, they write, let's say 3x. then now it's no longer invisible, but it's a visible number there. Just like there, if they say 3 square root of that, then there is a visible number being that. But the moment they just say square root, just know there is an invisible 2 there. So how it works is that, let's say you have square root of x. There is an invisible 1 there, there is an invisible 1 there. So this thing, it means there is a law which says it is the same as this x being the base. You see this exponent being 1, you write it at the top, you say over whatever that you are having there, which is 2. So the reason why this one that I've just explained, the reason why it ends up being just a, it's because it's like you are having square root of a. So now let's work it out. There is an invisible 2 there, invisible 1 there. So that means this thing, according to what I've explained, is the same as a to the exponent of 1 over 2. Just remember that outside 2. And you remember that law of exponent which said if you are having a base to the exponent something and raised to another exponent, it's like you are multiplying this by that, it ends up being a to the exponent 1 over a 2 that you multiplied by 2. So that is why half of half is 1. Or if you say half times 2 is 1. I meant to say half of 2 is 1. That's why you will have a to the exponent of invisible 1. Because that cancels with that, and then you just have 1, which is not necessary to write, but we know it's there as an invisible 1. I hope this part makes sense. Looks like I've gone deep into the surds. Maybe let me just do I'm thinking if I should do few examples so that at least we will know that with regards to the surds we are sorted, just so that when we get to the special angles we know you don't have the problems regarding the surds. Let me do some more examples. Let's say, for example, we have 5 that is being multiplied by square root of 7. 5 multiplying square root of 7. This one, it should actually just be 5 square root of 7. Why? Because it's like you are having a term there being a multiplying another term there being square root of 7. I'm putting it as b. Just be aware there is invisible 1 there. There is invisible 1 there. So this 5, it is multiplying that invisible 1. That's what is happening there. Even though this one of the letters, it's not necessarily a valid example that I can continue to explain, but I just wanted you to be able to visualize. So the reason why you are having 5 there is because 5 times 1 is equals to 5. This one, it remains as it is. So maybe let's look at another example. Let's say you are given 3 square root of 5 that we multiplied by square root of 2. So this one, it should therefore be equals to. There is an invisible 1 there. So that means it is this multiplying that. Then 3 times 1 is 3. This ones of the square roots, what did I say? You don't have to do square root, but you do 1, and then whatever that is inside, you multiply it with whatever that is inside the other square root. Then you end up having 3 square root of 10. You can still punch it on your calculator. Punch that. No, that one is an answer. Punch that. Check what it gives you. It should give you that. It mustn't be a decimal. Punch that. Definitely it should give you that. It mustn't be a decimal. So I'm just saying when you punch it on your calculator, it should just give you exactly how I've written it. So then maybe let's look at some more examples. Let's say this time around you are given, let us say square root of, what is it? Let's say square root of 3, we close that and then we square it. what will that be? I think according to what I've explained, it should actually be, it should just be 3, because my understanding is that this thing, it means we have 2 of exactly the same thing. It means we have 2 of exactly the same thing. And if we have 2 of the same thing, this multiplying that. Remember, a multiplication can be in many forms. You see now, I'm doing this deliberately so that you can see that it can be in the form of the brackets or just a dot like that one, or the normal multiplication. It means the same thing. So what we know is that, what did we say? We will just have that one thing, and then this multiplies with that 3 times 3. Then what will that be? It ends up being square root of, what is 3 times 3? Definitely that is 9. What is square root of 9? We know it is 3. So this is a lengthy way of working it out. Otherwise, there are many ways in which you can work it out. That other one that I've shown you with the letters, that's if you have a letter, because you can't say letter times letter and it gives you a number, of which when you say square root of that number, it gives you 3. So remember, you might need to redo this exact same problems that I'm doing before you can attempt any exercises, before you can attempt any exam. Redo exactly what I've done. Just take that C, write it on the side, and redo them and check if you are getting them correctly, so that if you do an exercise and it looks a bit different, at least you've got a knowledge base that you are referring to. So maybe let me add another one. Here, what am I going to do? Let's say we have, this time around, it is 5. Let's say square root of 2, and then we square that. What an interesting question. This one is interesting because you will need to apply the laws of exponents. You remember the one that says b, when you multiply it by that, and then if you square it, then it means this squared must multiply the exponent of that base and the exponent of that base. So you have 2 different bases there. So it ends up being a squared multiplying b squared, because it's like that one a being invisible times 2 and that one being invisible times that 2. So now it's like you are now having this 5 that you need to multiply it by that, meaning 5 to the exponent of 1, it multiplies that. And then again, you still have this one of square root of 2 that must also multiply that. So you have that invisible one there that must multiply that. That's why I'm having that there. This squared, what will that be? 5 squared, definitely that is 25. And by now, we do know very well that when you say square root and then you are squaring there, it is just actually removing that squared, and then you just end up having 2. So maybe let me just explain this part for the last time. This one of that. Always when you say square root of something and you square it, what it does, automatically it removes that square root, and then you just remain with whatever that is inside. Even if the inside is plus x, then it means it will just remain as plus x as long as you square it. Just be careful of that. Then you end up having it should be 50 there. That one, it definitely should be 50, because 25 times 2, it is 50. Let me do some more just so that at least you'll be exposed to enough of this type of problems. I think I might have to do a separate lesson that you can watch on the next lesson, otherwise tomorrow, where you just focus mainly on the special angles, just so that at least you can have this full lesson and separately do the problems related to the surds, and once you're confident, you will therefore move on to the special angles, because you will need this knowledge, and special angles are more easier than you having to understand this, which means if you can fully understand this, then you will be in a better, if not a good position, to be able to deal decisively with the special angles. Okay, maybe let's look at this one, which is a fraction. Let's say you have 2, which is multiplying square root of 5. It doesn't matter whether we are dividing there, honorable member. It really doesn't matter. What you should just know is that this 2 is multiplying that invisible 1. That's why you'll have 2 square root of 5 over this negative 3 is multiplying invisible 1. That's why you'll have negative 3 square root of 5. I hope that part makes sense. Definitely, the square root of 5 will cancel with the square root of 5 and you end up having 2 over negative 3. Remember, this 2 over negative 3, this is the end of it. Nay, I'm just exposing you to how else it can be written. It is still the same as negative 2 over 3. And again, it is still the same as negative 2 over 3. You can choose whichever way you want to write it. So that means that negative can belong to 2, it can belong to it as a fraction, it can belong to the negative 3, meaning it can go to the numerator or the denominator. Doesn't really matter that much. That understanding, you will need it at a later stage when we continue, but just be aware of that. Okay, so now let's do maybe this last one. I'm just hoping that it does look complicated. I'm just hoping that you will fully understand it. Let's say square root of 2 there. Yes. Let's maybe do it this way and say, the moment you are given a fraction, honorable member, you see there we have a fraction, but there we don't have a fraction. I did say let's force this one to be a fraction. How do you force it? You will always divide it by 1 because 1 doesn't change anything. Okay, so what did I say? I said you just have that one fraction, this multiplies with that, and then you have 1 square root of 2. That one is there as invisible 1. So now I don't need to write it, I can just leave it as that. And then you remember what I said. After there, you cross multiply. So that means the 2 will be cross multiplying with that square root of 2. And then the 1 will be cross multiplying with that 2. And that should be the end of it. So that's how you deal with it, honorable member. That's definitely how you deal with it. So as I conclude this part of the lesson, let me just show you how the special angles look like, so that on the next lesson at least you will know what to expect. Remember, I said we have, what did I say? I said we have special angles of 30 degrees, 45 and 60 degrees. So those are right-angled triangle, whereby that angle is 45 degrees. Doesn't matter if you write it there. Again, it doesn't matter if you write it there, because those angles are equal. So the opposite side will always be 1, the adjacent side will always be 1, the hypotenuse will always be square root of 3. This is the special angle of 45 degrees. So maybe it is a special angle because it doesn't change. It is always like that. Then another one is this one, whereby there you have your 60 degrees. So this one, the adjacent will always be a 1, and then the hypotenuse will always be 2, and the opposite will always be square root of 3. The last one, I don't have space. Maybe let me do it there and say the last one, it is this one of 30 degrees, where the 30 is there, and then the opposite will always be 1, and then the hypotenuse will always be 2, and then the what is it, the adjacent will always be the square root of 3. Yes, I'll leave it here. This is what I wanted you to be aware of.